First, quick review of the angles that land on the line in radians. I know we can always, guys. I know we can always use the calculator. I will never, get on you for using the calculator. All right, but there's just some I want to know very quickly without wasting time going to the calculator. So you have 90 degrees. Anybody remember 90 as a radian? Pi over 2. Anybody remember 180 as a radian? Just pi. How about 270 as a radian?
3 pi over 2.
Thank you. And then we just went over, what's 360 as a radian?
2 pi.
All right. Again, just some that I know you can use your calculator. I would just like to go quicker, and you'll see why it's so nice to know some of these today. All right, 3 more now. 3 more common ones that I don't want to have to use the calculator for if I don't have to. But on the first, doing it for the first time, I would expect you guys go ahead, use your calculator. Give me 30 degrees as a radian. 30 degrees as a radian. So 30, go to your toolbox, units, constants, degrees, see what it is in radians. And what do you notice? 30 degrees is? Pi over 6. Let's see if we can remember that. I guarantee by the time you walk out the door, you'll have that memorized by the amount of times we're going to need it. All right, 60 degrees. Pi over 3. And 45. Pi over 4. All right, let's see if we can do this today without going back to this page. Okay, let's see if we can remember these without going back to the page. Okay, all right, let's see if we can. That's our goal. Before you leave today, knowing these 3 without going back or going to your calculator. All right, here, guys, I'm not really showing anything new today. I want to use what I've taught you to do these problems. It's not like a new set of steps I'm going to give you. Here's what I'm going to do today. I'm going to give you the quadrant we're all in and the reference angle. What was the original angle? Okay, what was the original angle? So you look at part A, what quad are we in? 4. Quad 4. And the reference angle there is pi over 6. We don't deal with that. Stop. Can anybody not look back? Pi over 6. What is it? 30 degrees. 30 degrees. Good. Also, too, here's a little way, too, I always remember. Pi is always what? What's pi in degrees? 180. 180. So anytime you see a pi, you can think 180. 180 divided by 6. Brady, what'd you tell us? That's 30 degrees. So this is 30 degrees right there. All right, draw yourself the XY axes. Let's see this visually. In quadrant 4, can you draw a 30-degree reference angle in quadrant 4? Remember the reference angle. It's got to be on what axis? X-axis and the terminal side. So that angle right there is 30 degrees. Pi over 6. Everyone ready for? What is the actual angle in quadrant 4? That's what I'm looking for. Your help right now. The reference angle is 30 in quadrant 4. What's the actual angle? So I know it's got to be between 270 and 360. Somebody better give me an answer between 270 and 360 here, right? So using that info and knowing where you are, let me get my mug shots and we'll talk to somebody here. I already got it set up. Perfect. All right, Chris, good talk. One job, be here. Gia, want to talk to me here? Talk me through this? How do I find that angle? 360 minus 30. So that's going to give me 330 degrees. Awesome. Any questions on how Gia found that? Ooh, now the next test. Well, what do you got?
Aren't we supposed to convert that to a round?
Why don't you let me teach? You always want to be up here. I get it. That's my answer in degrees, but it also says find it in Radians. Drop the calculator. Drop it. Don't even no. Watch how quick this is going to be. What was my reference angle again? Pi over 6, which was what? 30. How many 30s go into 330? You can use your calculator if you want for that. How many? 11. Right? Oh yeah, everyone, 11?
Yes.
So remember that pi over 6, which was 30 degrees? How many times does it go? How many 30s go into 330?
11.
There it is. 11 pi over 6. We didn't need the darn calculator for that. I already knew pi over 6 was 30. How many 30s went into 330? 11. So that's got to be 11 pi over 6. Hey. Done. Didn't have to go to the calculator. We can do this without it. Next up. Pi over 3. Don't look back. Pi over 3. How many degrees am I working with? 60, right? Well, pi is 180. 180 divided by 3. So this is 60. Can you set that up in quad 3? That reference angle in quadrant 3. X-axis, terminal side, forms a 60-degree angle. Make sure it's with the X, not the Y. Not the Y. And we want to know what is that angle in the third quadrant. So before I call on anybody, you better have an answer between what? 180 and 270. Yeah, we should have an answer between 180 and 270 if it's in quad 3. How are you going to get there for me? You know that reference angle 60. How do you get to the angle in the third quadrant now? And look, I'm not teaching anything. You're using your knowledge right now of where everything is, what the angle measurements are. All right, talk to me here. Talk to me. Samir, anything? What's that? What's the angle here? 180. But then I went in an additional how many degrees? 60. So that angle in the third quadrant is going to be what? 240. Everyone okay on the degree measure, how we got it? I went 180 and then the additional reference angle of 60 degrees. All right, ready to turn this into radians like that. It was pi over 3, right? Pi over 3, which is 60. How many 60s go into 240? How many 60s go into Henry?
4.
4 pi over 3 then. Okay, that's why it's beneficial to know these. And I don't ask to know a lot. I know 3 of them. Yeah.
How come you're like 360 minus 30 and then you add all this?
Okay, say that one more time.
Like, why are you subtracting on the first part?
Okay, what quadrant was I in the first one? 4. 360s right here, right? And to get that angle, I needed to take away the 30.
Okay.
Here, what quad? I'm in 3 now. A little different rule on 3. Now, I went from here to here, I went 180 plus another 60.
Okay.
If I took away 60, I'd be in quadrant 2.
So you're not ever going to do like 270 minus?
No.
Okay.
270 and 90 never come out of your mouth because they're on the y-axis.
Okay.
We're always on the x.
Okay.
So it's either working with 180 or 360. Good deal?
Yeah.
Good question. Anybody else? All right, next up. Now we're in quad 2. Reference angle pi over 4. Don't look back. Pi over 4. How many degrees? Pi over 4. 45. Yep. So get me a quadrant 2 angle with a reference angle of 45. Here we go. Make sure. Look, I could put the 45 either spot, but it's here. Reference angles are with the x-axis, not the y. Make sure it's the angle on the x-axis. And then now you are finding me how many degrees are in. Should I I do another color there. In that second quadrant angle. So we're looking for something between 90 and 180 here. Woo! Talk to me. How do I find that angle there in the second quadrant? I know that's 45. Brennan, now you can show off.
So you take 90 plus 45.
Well, that would get you there just because it's 45. But I don't want to use 90. I want to use something on the x-axis, though. So I want to use 180. And then, okay, yes. And then look, Brent, I'm not going to argue with you here because if you did 90 plus 45, it's because Brent, 45 is right down the middle.
Yeah.
But if that angle was 30, you can't do 90 plus 30. See what I mean? It just works because it is 45 and 45. All right? And then what's that end up giving me there, kids? 135? All right, how about it in radians without going to my calculator? I know it's pi over 4. How many 45s go into 135? So it's 3 pi over 4. Now, hey, guys, I am not going to put you, move you down a peg or think less of you if you go to your calculator and convert 135 to radians. That's fine. All right, it's fine. I'm just going to go quick in class, though. I don't have time for that in class. But if you do that on your own, fine. It's fine. Any questions here? Yeah, you're having a good time. Next up, there it is. Sketch an angle, find the reference angle in radians. Now, I say no calculator, but if you need it, you need it. I want you to see how quick this is going to go now. This is going to be great. 5 pi over 6. I want your help graphing it. I ain't got no time for calculators. You know what I'm going to do? Pi over 6. What do you got for me? Pi over 6. 30 times 5. What's the angle? Done. Julie, see how easy that was? Pi over 6 is 30. 30 times 5. Oh, that's a 150 degree angle. Go ahead, graph 150. This is day 1 stuff now. Day 1 stuff. Where's 150? Gia, where's 150? Which one? Quad 2, thank you. Closer to 180. Please don't forget about your rotational arrow that starts on the x-axis and goes towards the terminal side. And then there is one more part to this question, which is what's the reference angle in radians? Don't care about degrees here. What's the reference angle in radians? If you want to find it in degrees and then convert, that's fine. So why don't we start there? What is it in degrees? What's the reference angle there in degrees? Sticks here, Grayson.
30.
30. Oh, what's 30 in radians? There you go. Oh, wait. Hey. 5 pi over 6 was the angle, and look what the reference angle came out to be. Pi over 6. That's a coincidence. Wonder if that's going to keep happening there. Next one. Can I have your help graphing negative pi over 4 for the second one? Anybody pi over 4 today? 45. You guys are already good at this. So that's going to be negative 45. I think most of you could handle that being negative, but if not, make it positive. How do you make it positive? Add 360, yeah. I think some of you know where it's going to land on negative 45, but if you don't, add 360 to it. And you're actually going to end up doing 315. Either way, negative 45 or 315, what quadrant does it end up in? Julia?
Quad 4.
Good, quad 4. Ooh, and this one is what are you going to tell me when I say what it's closer to? 270 or 360? It's the same. 45 degrees away from both. Darn right, Brady. So I'm going to do that thing halfway down the middle. And just be careful here. Where's your arrow going? Because I didn't ask you to graph 315. I asked you to graph negative 45. So which direction? Clockwise. And what's the reference angle here, huh? Don't look at the y-axis, right? We're looking here. 45, yeah. Reference angle's 45. But in radians, that's pi over 4. You guys noticing a pattern between the original angle and what the reference angle comes out to be here? You can just kind of pluck it off. But we'll see here for the last one. 7 pi over 3.
420.
You and Brennan, how about you just relax here?
Thinking.
All right. Next time you have a thought, forget it. Okay. Pi over 3, what do we have? Pi over 3. 60 times 7. Yes, that gives me 420. A little too large for us, right? A little too large for us. So let's subtract 360 from it. And what do I get there? 60? Is that really 60?
Yep.
I don't know why I'm asking this, but what quadrant am I in then? Samir, 60 degrees, what quadrant? First quadrant. Closer to 90. Oh, hey, be careful with what's the deal with your arrow here? Because if you just do this, you graph 60, but that's not what we graphed. We're graphing 420. So around to 360, then to your terminal side. And then finally, reference angle, 60. Yep, which is also known as, in radians, pi over 3. You guys seeing? Look. Pi over 3, pi over 4, pi over 6. There's my reference angle. It's not bad. Well, I got one more here, the finisher. See how far you come. No graphing unless you need to. Tell me what quadrant we're in and find the reference angle. Didn't we just do 7 pi over 6? No, we did 7 pi over 3. All right, 7 pi over 6. Pi over 6 without looking back. Pi over 6? 30 times 7. 210? 30 times 7. Not 60 times 7. 210, yep. Okay, and again, I can't stress this enough. I know we're just doing this without our calculators, but if you need to convert it on the calculator, you do it. You do it. I'm not going to shame you for it. Do it. Where's 210? Oh, actually, I should probably call on somebody. Where's 210 here? Julia, where's 210? Watch your mouth.
3.
Between 180 and 270, quad 3. And then you ready for the reference angle? Reference angle. We're going to leave it in radians too here. If you've been seeing the pattern, you know what it is already. But just to show you, reference angle is going to be what? 210 minus that 180, which is 30, which is what in radians?
Pi over 6.
Right? I just detach it. I just detach it from the 7. And final one. Pi over 3 again. 60 times negative 2. Yeah, look at that. We're becoming pros. If you don't like negative 120, you better add 360 to it before I call on you for what quadrant it's in. Maybe some of you, or hey, if you don't need to, some of you might be able to tell me what quadrant we're in with negative 120. But hey, I'm an add 360 kind of guy. So we're looking at 240 now. What quadrant we in here? Julia, back to you. Quadrant, come on, redemption.
Quad 3.
Yeah, there we go. Quad 3. So the reference angle is going to be now 240 minus 180. Oh, shocker, kids. Shocker! I couldn't have known this at the beginning. What's the reference angle? 60, which is pi over 3. Bam. Oh, yeah. Get that Chromebook out. No Delta Math. Just flip over your packet right now, please. No Delta Math. So why am I asking you to get the Chromebook out? So you can check your answers. Here we go. So there should be no typing needed once you have the answer key up. So if you're typing, I'm not too sure what you're doing. Probably not the assignment.